Welcome to the CompTIA A+ 220 1101 or Core 1 exam. This is Objective 3.1, Copper Connectors. If you've connected a traditional analog telephone or your DSL on your network, you've probably used an RJ11 connector. This is referred to as a 6-position, 2-conductor connector because although there are 2 wires inside of this connector, there are actually 6 positions where other wires could be. And in fact, you might find an RJ11 connector that has some additional wires inside of it. So there may be 6 positions and 4 conductors. This is commonly used for phone connections. And if you're plugging into a DSL modem, you'll often find the RJ11 is right on the modem itself. If you're connecting the Ethernet, then you're probably using an RJ45 connector. It looks quite similar to an RJ11 connector, but this has 8 positions, 8 conductor connections. You can see all 8 of these on the conductor on the back of a RJ45 cable, like in the picture below. This is commonly used for Ethernet, although you might find RJ45 for other types of connections as well. This is the back of a DSL modem. You can see the DSL connector is the smaller RJ11 on the left, and then there's Ethernet LAN connectors on the right that use RJ45. If you have cable television, then you're probably familiar with the F connector. This connector is used on a coaxial cable, and it has a threaded connection at the end to physically screw onto the connector so it can't easily pull off of the device. You might also use an F connector if you subscribe to an internet connection from your cable company. This is usually brought in with a standard called DOCSIS, which is Data over Cable Service Interface Specification. Here's the view from the back of a cable modem. We have a male F connector connecting to the female side of the F connector. It screws onto the connection with these threads, and that keeps it in place so that it can't easily be removed from the cable modem. If you work in a data center or a large computer room, you may have a number of punch-down blocks on the back of the wall that's used to connect users to the network. This looks like a wiring panel, and we'll take a look on the next slide. Notice how this punch-down block patches out into different cables. This is allowing you to permanently attach wires to a wiring block, making it much easier to manage these wires in the data center. Here's a close-up of the wiring block that you can see in this picture. Look at the wires that are punched down. They were punched down with the tool. You can also see that the connectors push through the insulation of these wires, and they make contact with copper that's on the inside. Here's another picture. Take a look at these punch downs. This is on a wiring block, and this has a punch down on each side. And if you're to see the other side of the block, there would be RJ45 connectors to complete the circuit. Let's take a look at USB types, because those are copper as well. Another set of connectors are the universal serial bus, or we call them USB for short. All kinds from USB 1.1 to 2.0, we have A, we have B, mini B, and micro B. These are all copper as well. We typically use these for mobile devices or other devices for your computer. However, over the years, we noticed that we have higher needs for bandwidth and different throughput. So USB 3.0 is a much better technology in that regards. You can see that they are quite similar looking, but they have a blue color, and the micro is not quite the same. And USB-C looks quite similar to micro B. We were talking earlier about USB Type-C. Take a look at these two connectors. They are very similar. This USB connector is double-sided, so there's no top, there's no bottom. You can plug it into either orientation, it doesn't matter, which is not the same for micro USB. Both of these devices will create serial connections. We can run different signals through USB cables. So you might see the serial connectivity like Thunderbolt devices or DisplayPort devices as well. One type of wiring connection that's been around for a very long time is the one that we refer to as Molex connector. You'll find this on older devices or legacy systems, more likely to connect different motherboards and components. This is a 4-pin power connector. It was originally created by the Molex company. AMP makes a version of this connector called Mate-N-Lock, and the single connector is designed to provide both 12 volt and 5 volt power for devices inside your computer. So if you have a hard drive or optical drive that needs power, or you need to power up fans that are inside your system, you may be able to use these Molex connectors. One way to tell if you have Molex connectors available on your computer is just look at the power supply itself. It's pretty easy to spot these connectors because they're 4 pins. If you have an Apple device, you may be using a Lightning connector. This is an 8-pin connector that's used to transfer data and provide power for certain models of iPhones and iPads. The Lightning connector was introduced when the micro USB was common for mobile devices. But Lightning allows us to have additional power output, especially for those larger phones and tablets. And unlike micro USB connectors, the Lightning connector doesn't have a top or bottom. You can plug it into either orientation and you're good to go. If you spent a lot of time with network infrastructure or you've been in a data center, you might be familiar with this type of connection. This DB9 stands for D-subminiature connector, and the size of the connector is B size that supports 9 pins. These are commonly used to send RS-232 signals from your device, commonly to a serial port on the other device. This was originally used for modems and other serial devices. But if you're working in a data center these days, it's going to be common to see these on switches, routers, firewalls, and other network infrastructure devices. Okay, we're at the end of Objective 3.1, connectors. Which of the following is not a copper connection? Apple Lightning cable, Molex cable, USB-C cable, or optical fiber cable? And the answer is optical fiber. There's absolutely no copper in here. We just have cladding that bounces around with a ray of light. Thank you for watching.